Thank you, everybody, and thank you for staying this late, especially the fact that we've gone over and you're still awake. That's great. So I'm excited to tell you more about our flexible logistics and exploration rover at Astrolab, which we call FLEX in short. So Astrolab is a startup based in Hawthorne, California, which employs about 20 to 30 engineers with a lot of experience working on lunar and Martian rovers, on almost every single arm that was flown on the Martian rovers, as well as numerous missions at JPL, SpaceX, etc. I'm very excited to be working with this team that basically has a vision of a multiplanetary future. And I imagine the fact that you're sitting here in this audience today tells me that you believe in the same thing. Otherwise, you wouldn't be attending a lunar symposium. So we think we're today at this crazy inflection point, thanks to all of the investments that are going into reusable, fully reusable, let me say, rockets, rovers, landers, and all the equipment that's being invested in today. And in fact, there's been about $1 billion of investment in the past decade, which is a threefold increase compared to what it was a decade ago. So there's been a lot of traction, which basically allows us to have unprecedented access thanks to these reusable vehicles, like what you see right here, which is the Starship vehicle. I'm sure you're all familiar with it. And what we believe is the next evolution of what's needed in order to enable last mile logistics is a rover. Similar to the previous presentation you saw, we believe in that vision as well. And the Flex rover that we're designing, unlike most rovers you see today, it has actually a lot of payload capacity. It can carry 1.5 tons of payload on the surface of the moon, and it can go at 15 kilometers per hour top speed. It's semi-autonomous, and it will stay on the surface of the moon for a period of up to 10 years. And I'll tell you more about it soon. Oh, what happened to my presentation? Oh, maybe we can skip the video. It's not playing. Well, I was excited to share a video with you, but every time I press on it, it closes the presentation. Yeah, let's skip to the next slide. This 6. You can go to slide 6. Thank you. Okay, so the Flex rover is designed to be very versatile, meaning that it's modular. It can carry, 2 fully suited astronauts, or it can carry, multiple tons of cargo, or both. And the reason why we've designed it this way is in order to enable not only, NASA human exploration missions, but also all the other infrastructure that we're going to need to build on the moon. And the next slide. So, today it's an amazing time to be living. We thanks to rockets such as Starship that are going to be landing on the moon circa 2025, 2026. Don't ask me the exact date of these missions, because well, not public knowledge. We are basically enabling a feature similar to what you see with cargo ships, where they come into a port with a lot of shipping containers, and then trucks and trains to get things to where they need to be. We see a similar future, and that's why you're designing large rovers that will take cargo out of the Starship garage, they call it, down an elevator and to destinations where habitats and other things will want to be established. We'll be able to take multiple tons of cargo, not just what fits on our rover, but go back to the Starship lander and pick up packages and deliver them where they need to be, so that we have a very nice end-to-end system. Our rover is designed to enable a lot of different kinds of missions in this fashion, and it's modular in the sense that your payload doesn't have to be assigned. We also have other type of payload accommodations that are in like 12-year form factors. So don't worry if you're not like 2-ton payload and you want to do a mission, you can still enable them. But also for future missions, it's easy to do that as well. As you see, we have 2 solar panels on the side that deploy. We have a 6-system robotic arm connected to the rover that can deploy those payloads out of central 12U compartments or other types of compartments that we have on board. And the really revolutionary thing that it can do is establish all the types of infrastructure around the moon, that vertical solar arrays and power systems that are needed to enable more energy-intensive types of applications on the moon. The rover has capabilities to enable ISRU, all types of extraction applications, as well as transporting humans. Fully soothed astronauts, we believe, are easier to be transported in the standing configuration thanks to all the equipment that they have. So we'll pick them up on Starship, Lander, and other landers that enable human landing systems and transport them to eventual habitats and other things that they'll want to do. Hopefully enable all the missions that you guys are working on as well, be it manned or autonomous. You can see the wheel, the chassis, all the support is designed to be able to withstand all the different slopes and environments. It can do crab walks and all of the types of different configuration with the wheels. And we eventually anticipate to have not just one lander, but multiple landers on the moon that can enable creating habitats and things of that nature to build larger scale infrastructure for the needs of astronauts and others. That configuration over right there. And we are not, we're kind of lander agnostic. Yes, we are going to go on the first Starship mission, but we can also go pick up cargo from other landers, such as Blue Origin and other heavy lift vehicles. And we hope to standardize the payload that come off of these and be able to go pick them up and transport them where eventually. Here's showing an application where we're enabling resource extraction and manipulation, and we can take these samples back to other sample return missions, and enable the full lunar economy. So we see transport as a piece, transportation and mobility as a piece that really needs to be developed to enable the future. 1 minute. Okay, so I'll go through this quickly. I already talked about our robotic operations. The robotic arms that we've developed can also operate in 1G, so we can use them here on Earth as well. They can carry 25-kilogram payloads and do all different types of extraction missions. We're going on the first Starship mission to the moon, and we've contracted somewhere in the middle of 2026 through 2028, carrying tons of payloads. We've signed customers already for this mission, but we do have additional capacity if you're interested in flying with us. We are doing quarterly field testing. So if you're looking to do analog testing, this is part of our culture. We do testing all the time, and we take our customers with us on these test campaigns. And this is just showing you our development plan. Can I go through it or? Okay, so let's see if I can do this in 20 seconds. So this is showing you the whole development plan. It starts with transportation and data logistics. And then we're going to move into enabling energy collection and storage, which we think is the next big piece, and distribution of that. And with the higher levels of energy, we can enable heavy energy use applications, such as extraction of resources on the surface of the moon, which will then lend itself to establishment of a permanent human presence. So I wanted to thank you, and sorry for all the technical snags today. My email is there if you have any questions about Astrolab or want to see some more of the videos I was unable to show. I'm happy to share that with you, and I appreciate your time today.